couple things. One of the things that we are going to focus on, obviously right now, is that there are times where we focus on proving right triangles congruent. And right triangles are unique because in right triangles, you guys know certain principles apply. Number one, you already know one of the angles every single time. Does that make sense? Yeah. Because it's a right triangle, one of the angles is 90 degrees. And so instead of having to say, ooh, that's a 90-degree angle, and therefore it's congruent, we're just going to say, if it's a right triangle, we understand. You already have one right angle that's congruent. It's kind of nice. It gives you one less thing to have to worry about. Okay. It also is constrained by the Pythagorean theorem. Right? The Pythagorean theorem determines the length of the sides of right triangles. So if I give you 3 and 4 as the legs, you already know that the hypotenuse is 5. Does that kind of make sense? So there's restrictions on what can possibly be the angles and the sides of right triangles. Okay, and so that's where these theorems come into play. So we've learned these guys before, and there's really one other one, okay? So I put these all up here, and I want to talk about them. I want to make sure you see this. Does everybody see this? They call this leg-leg congruence. Okay. But really, what's happening here? This is just side angle side. So for me, instead of making you have to remember more of them, we are going to recognize, like, oh, this is a right triangle, and we're just going to say the angles are congruent. Because if it's a right triangle, it has a right angle, and all right angles are congruent. So instead of learning more theorems, if you want to use leg-leg sometime, that's fine. But understand that's the same as using side angle side. If I went to the next one, oops, sorry. What about this guy right here? Yeah, this is angle side. Okay. So we already know that one. This is called HA, hypotenuse angle. Okay, or HA. If you want to call it that. All right. And then you've got this one. You've got this one as well. This is angle side angle, or log. Okay, leg angle. Okay. Now, again, if you want to use any of these, that's fine. You have to say it's a right angle, a right triangle, and then if it's a right triangle, then you only need to show me two things: a leg and an angle. Okay. This is the only one that is new. Okay. And it's not new. It's actually the one I said you couldn't use before. So we talked about there isn't a side-side angle or an angle side-side. That one does not work. There is, though, an HL. Because in right triangles, again, they're restricted. They can't do as much as normal triangles can do. Because if that one angle here is 90 degrees, okay, then all of a sudden, you actually know, if you know these two sides, what else do you know? If this is 5 and this is 4, what does this have to be? It has to be 3. That's not true for a isosceles triangle or an equilateral triangle or just a scalene triangle. That's always true for right triangles. Okay. Obviously, this is a scalene triangle, but it's a scalene right triangle. And so this is the one situation where that one actually works. Okay. Yeah.
Scaling is the side?
Yes. Yeah. That means all the sides are different, right? So 3, 4, 5. Okay, so this is the one we're going to focus on. So what that means is when we get to this proof right here, and you all saw, we did this the other day in class very briefly. Statement, reason, step number 1, you're given information. Notice what they gave you was the hypotenuse of both triangles. Step number 2, maybe you said the reflexive property. Okay, and then step number 3, maybe you said something like angle ABC is congruent to angle BCD. You don't even need to do that. All you need to do is say that these triangles ABC and triangle DCB, okay, are right triangles. That's just the definition. What's a right triangle? A triangle that has a 90-degree angle. Do these triangles have 90-degree angles? Yes. And so step 4, you say the triangles are congruent. Triangle ABC is congruent to triangle DCB by hypotenuse leg. Sorry, and this was our leg for both triangles. So notice on these, you do need to tell me this at some point. If you're using any of the ha, the la, or the double L, okay, right? Where you can, I don't want to call it a pair of L's because that's too close to parallel. Or whole. Like if you're using one of those, you're gonna have to say this. Okay. That's a for sure step on any of those proofs. Typically, what I have students do is ignore all the other ones and just know this one. So, if they ask you to prove 2 triangles are congruent, you guys have 5 ways. These are the 5 things you need to do for any proof where they ask you to prove triangles congruent. Side, 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 angle, side, angle, angle, side, and HF. Those are your 5. Okay? And only in a proof, those always go across from triangles being congruent. So don't use these any other situation but a triangle is congruent to a triangle. Okay. Right. You can pass up your homework now. Okay. You just pass it up to the front. I'll grab it.
No, I don't know what this is.
Well,
wait.
I
swear, let's go.
I guess we'll find out. As long as you didn't put Josh's name again.
Do you actually?
I did. I was talking to Josh and I'm
And then he erased it and then put his name. Alright.
What?
Alright, so back to your notes. So, in these situations, remember with me, you can be aware of either those 4, HL or HA or LA or LL. If you want to use those, again, I'm okay in this situation. Again, what it's asking you is determine whether these are congruent. Okay, if yes, so they are congruent, we would say that, yes, they are. What theorem or postulate applies, okay? And the theorem or postulate we would say? You could say side angle side, or you could say LL. Those are the legs of the right triangle. So the legs of the right triangle, two options. Number 1, they're touching the right angle, so the right angle's here and it makes an L. Or, so you can remember leg. Or the other side of that is if you know which one's the hypotenuse, it's not those ones. Right? So I always think of this as a little arrow. The right angle points to the hypotenuse. The other 2 parts are the legs. Okay? All right?
The hypotenuse is the longest?
It's the longest side. Yeah. Okay? Now, it does say, describe the series of rigid motions that maps this to this. And we're saying, how do I get from this shape to this shape? Yeah, this is just a translation. Okay? If you wanted to be really fancy, you could pull out a ruler and measure the distance and say it's a translation of this many inches. I don't expect you to do that, but you could. Bonus points. All right.
There's 1,000 bonus points, so mad. I don't need to read.
All right. Now, on this proof, I want you to see that I kind of half wrote the given, the right triangles. So I'm thinking maybe we could use one of the shorter versions. But they gave me this, and I wrote it down because I want to, obviously, this is important for me to talk about. I'm going to always start with this, you guys. So when you are sitting there working on a proof, that you have some kind of framework to think through, go through the given information first. Okay, I've got right angles. They're right triangles, which means there's right angles. So could I say those angles are congruent? Yes. Okay, so that's on the table if I want to go that route. Okay, maybe I want to use one of the shorter versions. Since they already tell me they're right triangles, I could use ha, la, lol, or HF, right? Okay, so you've got those. So I'm looking at this, and I'm like, okay, parallel lines. And when I'm thinking about parallel lines in terms of proofs, I typically am thinking one of two, in these proofs, either alternate interior or corresponding. Corresponding really comes up a lot more later. Okay, so right now, alternate interior. And I have that. If these two lines are parallel, cut by this transversal, I know that this angle here, angle G, I'm not going to call it angle G, but and angle E are congruent. So I'm going to write that out with a little more letters. We've got angle HGE is congruent to angle FEH. FEG. And that is the alternate interior angle theorem. If you have two lines that are parallel, they're cut by a transversal, alternate interior angles are congruent. That's what that says. So now I've got an A. Right? Yeah. So notice I've used all my given information. All right. Great. There's right triangles. Awesome. Thank you. Again, we could talk about maybe we want to show there's right angles. And those are congruent. I used my parallel lines. So now I've done all the given stuff. Now I shift and I look at my picture. And I'm like, okay, great. And when I'm looking at my picture, typically the two things that I'm looking for are what two things? Vertical angles and reflex angles. One of those two, yeah.
Is there a theorem or a thing that says if two lines are parallel, that means they're also congruent?
No. So notice, here's the idea, a couple things. If lines are parallel, lines go on forever, they actually have no measurement, so they're not necessarily congruent. And then, we've talked about this a little bit before, if you have lines that are parallel, sometimes they are congruent, like as in a parallelogram, they would be congruent. But if I gave you this shape, we've talked about this a little bit before, a trapezoid is defined by a pair of parallel lines, and they're not congruent. So, tricky. Okay. All right, so you guys said this one. You've got step number 3 here. We've got EG, or GE. Reflexive property. And so that's congruent to itself. And sorry, I erased that. I had this angle here was congruent to this angle.
Is there a theorem that says, like, if the parallel lines are congruent? Like, the sides are congruent?
No.
So you can't say, like, because then it would just make it...
It would, but yeah, you cannot say that.
Because aren't they the same thing, though? Like, the same thing? Sorry.
No. Parallelogram, yes, the opposite sides would be parallel and congruent. Trapezoid, parallel lines, not congruent. All right. Now, I'm okay at this point if you do one of two things. You can do this. You can do that. If you don't want to know that one, then what you have to do is you have to insert another step somewhere in there. Okay? And you have to say that angle F is congruent to angle H because all right angles are congruent. And then you could say angle, side. But you have to have that extra step. Does that make sense? Okay. So call it 3.3b. Okay. Yeah.
Isn't it
Angle. Angle. Notice your side is here. Is it between the two A's? No,
I
it's.
don't understand the order.
Yeah, so if we were talking about angle, side, angle, the side would have to be this side right here, and so I would have written my little side right there. Right? It has to be between the two angles. Here's this angle and this angle. So it has to be between. If you're going to say angle, side. Like physically, again, don't worry about the way you write it in your proof. Look at your picture and say, is that side between those two things? And again, meaning, I should be able to write it in such a way that literally it would be like right between them. Not just because I put it there, but, this is the side I'm talking about. That side's not between these two A's.
Okay.
That's why they call it the non-included side. It's kind of like it's being excluded. You got these two angles, they're friends. And here's this little side that's like left out. As opposed to their buddy that's kind of in the middle of them. That would be the included side.
So when you have the parallel lines in the given, that's not, like, you can't use that as one of your sides.
Right, because the sides have to be congruent. And those are just parallel. Alright, why don't you guys try this one? Notice for what Michael did, which is perfectly fine. What Michael did, you do not need this step at all. You've got your leg, you've got your angle, and therefore the triangles are congruent by this. If you wanted to use this step, then what you would say on the bottom, okay, is angle, side. Angle here. Ooh, sorry.
Wait, is the
Angle, side, angle. Angle, side, angle. My apologies. So angle, side, angle. Notice, those are labeled for us. It's this angle down here, this angle up here, and the side that's in the middle of the two. Now, guys. Now listen, because I'm telling you. Just want to throw it out there for you. If for some reason this is the way you were thinking, you could throw out right now the third angle theorem, and you could say that J is congruent to M, and then you could say angle side if you wanted to. Like, don't feel restricted. Again, sometimes, right? Sometimes you think a certain way, and you get stuck in that way of thinking, right? I've seen that with students, like they do a problem wrong on the test, and then they'll be like, hey, let's look at it again. And they look at it like 2 or 3 times. And guess what they do? They follow their work and they make the same mistake every time. Right? Now, if I pull them aside for 2 days and then I pull it back out again, I'm like, okay, what's wrong with this problem? I write it out and I just copy what they did, but they don't see it. Then normally they can tell me like, oh yeah, you added instead of subtracting. And they normally say it with this sense of condescension, like, I'm a big idiot. And then I'm like, that's your work actually. I was just copying. So there are things like this one, step number 3, you don't need if you wanted to do LA. Okay? Or if you wanted to, and all of a sudden you just were fixated on J and M, and you wanted those to be congruent, then you can do the third angle theorem. It would just be like, you'd have, oh, okay, I got these 2 angles, now the third angle theorem. Okay? Normally, if you're saying the third angle theorem, the whole point was that they made the problem so that you had to say the third angle. But, okay. So, you've got